Let's take a look at scientific notation. Scientific notation is useful when we have really large numbers or really small numbers. Basically what it does is it saves us from writing all kinds of zeros. So let's take a look at how exactly we put a number into scientific notation and how we get it out. To put a number into scientific notation, it's going to be in the form something like this, where we have like a number, we'll say 2.1 times 10 to some power, and let's say 10 to the fifth, for example. That's a number written in scientific notation. The key pieces are, here we have times 10 to some power, and right here we're going to have one non-zero digit to the left of the decimal. In other words, this number right here needs to be equal to 1 or greater than 1 but less than 10. So that's that same idea of one non-zero digit here. So let's see how we go about writing one of those, a number in scientific notation. This is often referred to as standard form, kind of the traditional way that we look at numbers. To write it in scientific notation, what I want to do is figure out how many decimal places I need to move in order to get something where I have one non-zero digit in front of the decimal. And the reason that we have times 10 to a power is because our number system is based on tens. So each place that we move is a power of 10. So right now the decimal in this number is here right at the end of it. If it's not written, remember it's at the end of it right here on the right side. Then we need to figure out how many places we need to move it in order to get between this 6 and 5. We want one non-zero digit to the left of the decimal. So let's count that out. 1, 2, 3, 4, 5, 6. So we moved it 6 places. So that's going to be our power of 10. So it's going to be 10 to the sixth, and we've got times 10, and then our number which is left here would be 6.56 times 10 to the sixth power. Now, sometimes we have positive powers of 10, sometimes we have negative powers of 10, and here's a way that I can that helps me to remember if it should be positive or negative. Well, this number is very large compared to this number, and in order to make this number back into that one, which is what this is, the same number still, it's just written differently, we would have to multiply by a large number. Well, 10 to the sixth is a pretty large number, so it makes sense that this would be positive. If this was a negative power, that would be a very small number, which would make this number smaller. Well, this number is not larger than the one we started with, so we don't want to make it smaller, so the positive power is exactly what we should have. Okay, so let's take a look at this one here. In this case, our decimal is clearly written here, and we want to move it over, so we've got one non-zero digit to the left. So I'm going to go 1, 2, 3. Hey, there's one non-zero digit, so it's 2.03. So I write all those non-zero digits here, times 10, and we moved it 1, 2, 3 spots, so it's going to be 3. But notice, this number right here is much bigger than this one. To get this back to being that smaller number, this needs to be a small number, because if we multiply by a large number, 10 to the third, would be a bigger number, so this would get bigger. Well, this number right here is smaller than this one, so we don't want this to get bigger, we want it to get smaller, so that means we multiply by that 10 to the negative third power. So there's a couple examples of putting numbers into scientific notation. Now let's look at taking them out. Here we've got two numbers that are written in scientific notation, and I want to convert them back to standard form. For this first one, I'm going to take right here, I'm going to start by looking at that power of the 10, in this case a 3, and it's a positive 3. So what that means is this number, 5.02, is going to get larger. Which direction do I move the decimal to make that number larger? Well, I'm going to move it to the right. So I need to move it 3 spots to the right. So here it is. We go 1, 2, 3. So that number is 5,000. Oops. 5,020 in standard form. Okay? This tells me how far to move it. If it's positive or negative, tells me which direction. In this one, we've got 10 to the negative third. So what's that mean? Well, we're multiplying by a number that's less than 1. Remember, 10 to the negative third is a number less than 1. So we need to make this one smaller. So we're going to move it 3 places to the left. So 1, 2, 3. We're kind of running out of space here. But we can see that will be 0.00541. Okay? And it makes sense because when we multiply by a number less than 1, our number gets smaller. So scientific notation. If we're asked to write a number from standard form into scientific notation, we want to move the decimal an appropriate number of places so we get one non-zero digit to the left of the decimal. If it's already in scientific notation, we use that power of 10 to determine how many places we move it, and if it's positive or negative, that tells us whether we go to the right or to the left. I hope this video about scientific notation was helpful. Keep working hard on your math, and I know you'll do great.